Todd Gordon here with Inside the Race at the NASCAR R&D Center with Dr. John Patalak, Vice President of Safety Engineering for NASCAR, looking through the developments that they've made post the 541 wreck at Talladega and the updates that we've got coming forward.
Yeah, so here we've got the center section updates from a crash test that we ran to prove out some of the improvements we've made. So we can walk through those. All this gray steel, it's a 60 thou thick plate of steel that's been welded to the right side door bars. So when we looked at the 541 crash, this is not there in the current car. We did a lot of computer simulation work and decided on this solution. The reason it's all banged up and bent is we reconstructed that crash at a test facility and ran another car into this car. And we're pleased with the performance where we're hanging on to everything. We still do have bent bars, but minimal intrusion, much better performance.
And this was a full reproduction of that done at a test facility where you've got video for it.
That's right. We lined up the cars at the same angle and conducted the test at the same speed as what we had on the racetrack to prove out to ourselves that the computer simulations were correct and that this solution is good.
And you look at this and really the right side integrity here has been maintained. Let's go to the other car here that we've got out here to go through some of the front clip updates. So here we are in front of the modified front clip that we're going to come forward with at Atlanta this year. John, do you want to talk through the modifications that are made to this and what we've done coming forward?
Sure. If we start back where the firewall would be, so the driver would be seated back here, we've taken a lot of the steel structural members and we removed material from key elements to lower the buckling load or make the structure less stiff. So we have slots on both sides here. We've deleted some cross members here between the upright mounts. You can see we've also treated some of these areas down low. These would be some of the first areas that contact the wall of the front clip, where we've added slots to this ballast container as well as some holes. And it's all an effort to increase the amount of displacement we're getting out of the car to reduce the accelerations that the driver is experiencing. So these are the modifications that we're making to our existing front clips.
That's the part that all the suspension bolts to. So there's got to be some rigidity kept there. Beyond that, we've got the front bumper structure. Looks like you've done some changes there.
Yeah, so we were also, because we were able to soften the front clip a little bit, we could also soften our front bumper struts. Everything works together as a system, from the tip of the nose all the way back to the firewall. And so because we get more displacement out of our steel structures, now we can add some additional displacement in our aluminum structures as well. So you can see we've slotted these in the back. Both top and bottom received slots, as well as some initial initiators or triggers at the front side, all in efforts to increase the crush.
So if you look at how the crush happens in this car, it's going to start from the front and progressively work its way back. If it's a softer crush, it'll be the foam. If it's a little bit stiffer, it cuts into the aluminum pieces, and then once those have folded up, then you come into your front clip?
That's right. Yeah, it works all as a system, front to back.
Let's go back to the video that you guys did from the crash test, because I think it's really showing of how that deformation happens. Take a look at it. John, why don't you go ahead and explain what's going on here?
We reconstructed the 541 crash from Talladega, and we determined that it was an angle of 55 degrees and a closing speed of 59 miles an hour. That's the difference between the two vehicles. So that's what we ran here. You can see the overhead view. Here's an onboard view from the target car of the door bars. And this is with all of the plating and the updates in place on both cars.
Yeah, the front clip is updated on the impact car and the plating is done on the target car.
That's correct.
Let's look at the overhead of what happens with the front clips on that target car as it hits the crumple zone.
Yeah, you can see our current car. It hits the barrier and things begin to crush. We use up our aluminum structure, but you can see we don't use up as much of the front clip.
The car on the right side here, it definitely, you even see the motor move back, not too far, but you're seeing more displacement out of this.
Yeah, we wanted more displacement, but there's a balance. We also don't want to intrude into the driver's foot space or into their footwell. So we were able to do that with this test, with these updates we talked about.
And this is pretty big to lowering the G loads that the driver sees in an impact, right?
That's right, yep. We are reducing the crash accelerations that the driver is going to be exposed to in these kind of crashes.
So as we see from that video and what we just broke down, safety's not a destination, it's actually a journey. One of those things that I think you continue to evolve this car into what we've got going forward.
Yeah, if we remember back to when we started, we did a lot of the work in simulation. So we have one clip and it's got to live at Bristol and Dover and curb jumping at road courses and the wheel-to-wheel contact that happens every weekend. We needed to make sure that the structure of the car was strong enough to not bend during all of those things. And so a lot of that was done with simulation through these operational or maneuvering loads. That presents a challenge to crash deformation that we want to occur for the safety of the driver. So there's always a balance in all of that. So after we got a year of data under our belt, we can really go back with wheel force data, tire test data, and our teams are a huge resource, giving us data that they get in all of their K&C testing and pull-down rigs to really understand what are the true loads going through the front clip. And after we got that data after a year of racing, we were able to go back and make our simulations better, able to understand that we were conservative in the loads that we were asking the clip to carry. And that is what allowed us to make these updates, because we're confident that the clip can live through what it has to do on the racetrack and still now crash better with the updates in place.
Yeah, definitely. It's a journey, as we talked about to start with. I want to thank you for your time today and explaining this to everybody here and what you put into the safety aspect of our sport that makes what we see on TV such a spectacular event and one that we continue to make safer for all of our competitors.